trying to integrate as is would be nearly impossible. It's very hard to do it this way. Um, so you may have learned that if you want to integrate a squared plus x squared dx, you need the trigonometric substitution where x is equal to a times, I think, secant of x or something. Theta, secant of theta. Yeah, so you stick in this in here, and then you can do some integral. And that's terrible because here, a squared is this guy here for the z. So trying to do this integral is nearly impossible. So the goal is to change this into spherical. And often, instead of trying to go straight to spherical, it's nice to also think about cylindrical. So the question here is to try to change this into both cylindrical and spherical, and then evaluate the simplest one. Okay. Now, remember, cylindrical has the same z as the rectangular coordinate system. It only changes x and y into r and theta. So this part, you just have to make sure that you can rewrite this in terms of r and theta. Otherwise, this is basically unchanged. What's really needed is to figure out what's happening here. Okay, so let's try to see what's happening there. First of all, given that dy is corresponding to 0 and this is really y equal to 0 and y equal to 4 minus x, y equals to square root of 4 minus x squared. And this one is the top half circle of radius 4, right? So if you plug in 0, you get a 2. If you plug in 2, you get 0. If you plug in negative 2, you also get 0. So you can easily see that this graph must be passing through these 3 points. And then you've seen enough examples that you know that this is a half a circle. So that's a circle of radius 2, half circle of radius 2. And y equal to 0 is this one here. And dy means you're trying to paint going this way. So you start here and you end there. All the while, x goes from negative 2 to 2. So you get the full half circle this way. Okay? And how do you rewrite this in terms of r? Well, r will be painting from the middle, right? Yeah. So r goes from where to where? 0 until 2. Starts at 0, ends at here. And theta goes from where to where? 0 until? This is 0, and then goes all the way up till? Pi. Okay. And that means you have the integral from 0 to, so that integral is going to be 0 to pi. R goes from 0 to 2. And then I'll just leave it like this for now. dz, and then dy dx is going to be r dr d theta, okay? But then once you have r and theta, you're not supposed to have x and y, so these need to change. And that's not so bad. In this case, r squared is x squared plus y squared. Very important fact. So you can rewrite this again as 0 to square root of 4 minus r squared, square root of r squared plus z squared times r dz dr d theta. Okay, so that's going to be cylindrical. Okay. Now cylindrical, this is slightly better than this one. At least here you can immediately see that the means to change this will be, you write this as z equals to r times secant some angle. I can't use theta, so let's say phi. So that's another way to do the integral, but still, it's not straightforward. It's harder. Okay? we really need to change this to spherical. So how do you do this in spherical? Well, okay, so this is the platform where this is being integrated. This one says you start from z equal to 0, which is the xy plane, right? And you go up until here, z equals to square root of 4 minus x squared minus y squared. Okay, guess what this graph is? Sphere. It's a top half of a sphere, right? Because if you square both sides, z squared equals to 4 minus x squared minus y squared. Move everything here, you get x squared plus y squared plus z squared equals to 4. That's a radius 2 sphere. You can easily check by taking the xy trace, yz trace, xz trace. You can see it. And therefore, what's happening here is that if this is xy plane, this is the xy plane where z equal to 0 gives you an xy plane. And on this region, you go up until you get the top half sphere. Okay? And because you're only on this half region, you end up having a quarter of a sphere. It's like half of the top half sphere. That's what you're getting. Okay? All right, so how do you represent that as the spherical coordinate system? Well, spherical coordinate system is a three-dimensional system where rho gives you the distance from the center, right? So this time you're filling up the space by starting from the origin and shooting up till the boundary, right? And the boundary is given by this. But how do you represent this sphere using rho? Rho equals to? How would you get a sphere of radius 2 from the origin? That's a collection of every point that's distance 2, right? So this is what you get. Okay. Another way to say it is like, in one of the formulas for spherical coordinate system, rho is square root of x squared plus y squared plus z squared. And then you stick this in here, right? Then you get 4 minus x squared minus y squared. Minus x squared minus y squared cancels everything, and you end up with square root of 4, which is 2. So you get, using this formula, you immediately get that, okay? All right, so that's what you need. Rho goes from 0 to 2. And theta is same, 0 to pi. That's one of the benefits for doing the cylindrical before doing the spherical. You figure out where the theta should go. The range of theta is easy. Okay, and remember this is dV for cylindrical, but for dV for spherical, you need rho squared sine phi, and you need d rho d theta d phi. And that means the only thing that you have to figure out is what happens to phi. Phi goes from where to where? So, do you have an idea? Phi goes from where to where? 0 to pi over 2. Yeah. So, imagine that you have a sphere, okay? And we're only doing the case when it's a positive y. So, here's x, here's y, here's z. And we're taking this half sphere dome, and we're getting rid of the y negative part. So we only have half the dome here, okay? Now we have to represent every point inside this dome. How do you do it? Angle phi is north pole. Do we have something on the north pole? Yeah, we have something that's right on top. How low does it go? Until the equator. Equator is angle what from the north pole? 90 degrees from the north pole, which is pi over 2, right? So phi goes from 0 to pi over 2. Okay. And we're almost done here. Okay, so that's what you have. The only thing that we have to figure out, so all of these domains are now figured out. We don't have to care about that. The only thing that we have to figure out is this one, which is same as rho, right? So that's what we get. And this is what we need to integrate. All right, so I'll leave the calculation to you because it's overtime, but this is pretty straightforward. It should be easy.